definitions of geometry. Everything is kind of built on this. That's the only thing about this class. In algebra, you were kind of able to get like one chapter, then you got a different chapter. The thing with geometry is that it all builds. It's all going to build one on top of the other. If you miss a day, make sure you watch the lesson because we will need that the following day, okay? All right, undefined terms of geometry. We have 3 of them. This will be the first question on your test when you take this test. Ready? The first 3 undefined terms of geometry, the only 3 undefined terms of geometry are point, line, and plane, okay? A point. We all know what a point looks like. The only thing is that a point doesn't have a specific size. So in algebra, we drew our points and we labeled them, right? Label point A, label point B, and you just drew a dot and you wrote the letter. But a point can be anything, right? It could be the tip of your pencil. It could be the tip of a clothespin. It could be anything, but it just identifies a location. That's all it does, okay? When you write the point, I want you guys to just abbreviate point and put the letter A. So if your answer, because we're going to come across some answers that are point A or point B or point C, this is how I want your answer written out. Don't just put the letter. I need to know it's a point because a letter can represent several different things in here. All right, a line. A line is actually made up of infinite number of points that are put together. So if I take one point and I start putting them right next to each other really close, if Ms. Carranza can draw a straight line, there it goes. It starts to make a line as I continue to put them next to each other. So we'll see what lines look like, but they're actually made up of infinite number of points. Now, to name a line, you need 2, right? Let's suppose I have point A. And I said, all right, I want everyone to draw the line, and you don't have to do this. I want everyone to draw the line going in the direction that I'm thinking of. Do you think we're all going to draw a line going through that point in the same direction? No, right? Because it can go many different ways, right? Infinite number of ways through that point. So to name a line, you need 2 points, just so you know what direction it's going. So to name a line, you're going to use 2 points. And for instance, a line. Do you remember what your lines look like in Algebra 1? No. What did y'all have to put at the ends when you graphed? Arrows, because lines keep going and you cannot measure a line. You'll be able to measure one, but it's not called a line, all right? So they keeps going. We're going to make sure we draw arrows. So you're going to draw me a line to represent what a line looks like. So here we're going to draw a line. Here is point C and point D. So if I wanted to name this line, I can name it 3 different ways, okay? So I can name it line C to D, line D to C. Why do you think I'm allowed to name it both ways? Does it change the direction of my line? Does it change the direction of my line? If I call it CD and DC, is my line going a different direction? No, it's still going left and right. So as long as there's 2 points on the line, it doesn't matter which order. Just D and C, C and D, okay? One other way you can name it, one other way, is with an italic letter. That italic letter will be at the very end. So for instance, I'm going to call this line L. Line L. That's the only time you can use one letter, okay? So this is the way you're going to be writing out your answers, if that is your answer, okay? So if your answer is line L, you put line L. That's by the arrow. Or if you want to use points, you use any 2 points in whichever order. It doesn't matter, okay? This first unit is going to get some of you guys because it doesn't have any numbers. But it's okay. Tomorrow, we'll see some numbers, okay? All right, let's talk about a plane. So a plane is made of infinite number of points as well. So we have to have 3 points to identify a plane, okay? So what a plane is, it's like a layer. Like if I was to make an imaginary layer in this classroom, it would just be this huge, what is it, square? I don't know if this is a perfect square or not. But a huge square, just a huge little layer just laying here. And on that plane, there's all these points. But to name a plane, you need 3 points, okay? So look, the point, you need 1. A line, you need 2. So a plane, you're going to need 3. Good. All right, so we're going to use 3 points. Now, an example of a plane, like I said, if we had a little imaginary layer in here, that would be a plane. The ceiling's a plane, the floor's a plane, the wall's a plane. Any big space where we have 3 points that contain it, right, that we can use to name it. But by definition, it's made up of infinite number of points, okay? So this is what a plane's going to look like on your worksheet, though. It's going to look like this. It's going to look like a parallelogram. And you're going to have random points in there. I'm going to put points W, X, Y, and Z. That's a Z. All right. Are we in agreement that these 4 points are not like in a straight line if I was to connect them? Do we all agree with that? Right? They're all kind of scattered. That's how you want your points to be when you pick them. All right. So give me 3 points that I have there. Any 3, any order. Someone name them. ZYX. Okay. So I'm going to call this plane ZYX. Any 3 points. Someone else give me another name. 3 points. Someone else. Someone else. XYZ or WYZ? WYZ. So plain WYZ. Sorry, I just didn't hear the first letter. All right. And just like a line, you could use 1 letter, but this is the only letter you can use. So on a line, it was italic, kind of like cursive, and it's always going to be by the arrowhead. When it's a plain, it's going to be a capital letter, also italic, but this one's usually over at the corner. Now, what's the difference between this blue letter and all my red letters? What did the red letters have that my blue letter doesn't have? Well, it's blue, yes. What else? It has a point. The one that doesn't have a point, you can use to name the whole thing. Plain T. Now, it's really important you put the word plain. You use the word line if you need to. You use the word point if you need to. Whatever your answer is. All right. If your parents say they have a coworker, why would they call them a coworker? They work at the same facility, the same place, right? If you're cooperating, you guys are all cooperating in a group to get an answer, what are you all doing? You're working together, but the key word is together. So collinear means together on the same line. So collinear means 3 points on the same line. It could be any 3 points, and then just draw a line with 3 points on it. We'll call it R, S, and T. Okay? So non-collinear. Look, the only difference is the word non. Non-collinear are points that are not on the same line. So if you want to, you can draw the same line. Maybe not the same letters because I don't want you to get confused. I'm going to call this A, B, and C. Which point is not on the same line? B. That's why they're non-collinear. Okay? We're going through all the definitions first, and we'll put them to practice. Coplanar. Coplanar are points in the same plane. We've already looked at this. We said that to name a plane, you need 3 points. So here's A, B, and C. Non-coplanar is going to be different, so I need to give you a visual here. So a plane is like a sheet of paper on your worksheet, right? So this is going to represent my plane. And let's pretend this really big eraser is a point. I know it's really big, but we'll call it a point. So on paper, it's going to look like the plane is going to eventually touch the point. And that's not the case. So this is the thing about a plane. You see how it has 4 sides? Right? By definition, though, it shouldn't have 4 sides. It keeps going in all directions. If you look at the definition at the very top, it says extends. Yeah, can you see it? Extends infinitely in all directions. That means if this is your plane, right, that imaginary plane I was talking about, it keeps going in all directions. But we can't draw that, right? If it doesn't have a boundary, we've got to draw it somehow. So here's my question. If my hand is here, is my plane going to intersect my hand? If it was supposed to keep going, if by definition it's supposed to keep going, should it hit my hand? Yeah. Should it hit my hand over here? But it keeps going, remember? Yeah. How about in the back? How about in the front? Where should I put my hand so it doesn't intersect it? Under it or Above it, good. So, this is the thing about non-coplanar. So non-coplanar looks like this on paper, and this is why some students get confused. So you have your plane like this, and we're going to draw points X, Y, and Z. And I'm going to put point W over here. Now on paper, some students may argue, well, Ms. Carranza, you said it keeps extending. It's going to include W. Do you see how that student thinks that? Right? When I was talking about my paper in my hand, right? How it's going to include it. But this is not what it represents. When I say something is non-coplanar, it actually looks like this. This is your plane. Your point is either above or below it. So, if this is supposed to be coplanar, we're going to make sure it's in there. If it's not in there, then that point is either above it or below it. Now, your planes can go different ways. It could even be like this, going up and down. So in that case, above and below it won't work, but maybe what? In front or in back. Okay? All right, let's continue because I'm losing some of y'all. Zach, can you make sure you keep your head up, okay? All right, let's keep going. So on the left side of your notes, you have all the definitions. So we're going to put that to work. On the right side, we're going to do some examples. Ready? The first one says, I want you to name me a line that contains point W. So look on the left side where we had the word line. How many points do I need to name a line? A line? Two. Good. I need 2 points. And it has to contain W. So I want you to look for the line that has W. Has to contain W. Name me a line that contains that point. And it could be any 2 letters. Any 2 letters. VX. Good. So I'm going to call it VX. Put a double arrow on top. That means that's the line. That means it goes in both directions. Someone else. Different name, 2 letters, same line. XY? Anyone else? WY? Okay, now, I have 3 different names. They're all correct. You could also name them backward. So you can also call the line YW. All I did was change that last one by flipping it. Because the points aren't going to make a difference as long as they're on there, okay? All right, we got the line. Let's go to the next one. A plane containing point X. So here's point X. What is the plane supposed to look like on paper? Going sideways, kind of like a rectangle, right? Like a parallelogram. So how many points do I need to name a plane? 3. Good. Give me any 3 points in that parallelogram. Any 3 points. V, Y, W. The only problem is, I don't remember when we drew them, I didn't draw them in a line. They were all scattered. So I want 3 scattered points in that plane. Give me 3 points in that plane. Yes, Pablo.
W, Y, Z.
W, Y, and Z. Perfect. So he picked W, Y, and Z, and if I outline it, do you see how they're not all in a line? That's exactly what we want. So plane, W, Y, Z. All right, let's give it one more name. There's many different names we can give here. One more name using 3 points. Jojo, what do you think? Give me 3 points in this rectangle. VWX. Why doesn't that work, class? I just said what? They're on the same line. We want them scattered. VWZ. Good. So VWZ we can use to name that rectangle, which is called our plane. Plane VWZ. Now, I'm going to give y'all one last name. This last name is when we use the 1 letter. Remember we talked about this. It's 1 letter that's different from all of them. Do you remember which one I would use? The P. It's the other capital letter that does not have a point. This plane can also be named plane P. Good. All right. Collinear. Co together on a linear line, right? Together on a line. Give me 3 points that are collinear. Who would like to go for this one? Yes, Pablo.
VWY.
Points. So I'm going to call it points. V, W, Y. And that's how you would answer your questions, all right? Someone else, 3 points that are collinear, different arrangement. Catherine? X, V, W, perfect. Points, X, V, W. All right, and you want to use the word points, this is abbreviated. You want to use the word points because if you just put 3 letters, a plane also uses 3 letters. So I don't know what you're answering me. Are you answering me a plane? Or are you telling me it's a point? All right, last one. Give me 4 points that are coplanar. 4 points. Any 4 points in that blue region on our screen? Anyone else? Who wants to give it a try? Hamatula.
Y, Z, V, W.
Y, Z, V, W. And I know 3 of them are on the line, just as long as all 4 are not. So that Z is crucial. So I'm going to call it points Y, Z, V, W. And that's it, okay? So you're not going to have any numbers. We're just practicing the definitions. Look at the example. Look what we did here. I want you to try the practice, okay? Just try the practice. One got most of us. Most of us got the first name. If I call it line B to D, you got to make sure you're talking specifically about that line. And B to D is here. They've already identified that as a point. So if B to D is the line and I need to rename it, what can I do with that specific name? Pablo?
D and B.
D and B. You can just reverse it. So D to B, make sure you put your line notation, right? That identifies it as a line. The last one, a lot of you couldn't get that last one. The last one is using the letter. So on the example, I told you guys that if there's ever an italic letter right there by the arrow, that can be used to name the whole thing. So this is also called line M. That's the only time you can use one letter to name a line. The only time. Okay? All right, plain T. Who would like to give me an answer for plain T? Alessandra, give me an answer. Yeah, you had an answer, right, when I walked by?
Yeah.
Doesn't have to be right. You look on the left side, I need 3 points. Any 3 points in that parallelogram. Points meaning it has to have that dot next to it. A, B, and? But what happens with A, B, and C, guys? What's wrong with that one? They're all on the same line. A, B, and E. Now, there's many y'all can give me. A, B, and E. Y'all can give me different answers there. There's so many different answers y'all can give me. So here's a key question. Jojo, wake up, Jojo. All right, so here's my question. You can use any point in there, but when you're naming it, there's one letter you're going to have to include no matter which variation you use.
I don't know.
Which one do y'all think? If they all have to be scattered, all of them, and I'm looking at points A, B, C, and E,
B.
which is the one that you're going to have to include regardless?
B.
E.
But B's on the same line as the other one.
It's
It's going to have to be E. Because remember I said we don't want it to be on the same line. That one is not on the line, so we need to make sure we include E. So anything with the E is going to be correct. All right, what if I wanted to... Collinear means on the same line. Yes. We don't want it to be collinear when we're naming a plane. We want it to be non-collinear. All right. Next question. How can I name... Oh, I already named that one. Okay, let's go to the next one. Naming collinear points. Who would like to give me the name of collinear points? Catherine. Points A, B, and C. It can be A, B, and C in whichever order. If y'all wanted to write down points C, B, and A, that's correct too. But those are the only 3 letters we can use for collinear. All right, last one. Name a line that is coplanar with plane T. A line that is coplanar. That means the entire line needs to be inside inside that plane? There's only one answer, guys. What's the line that's sitting inside the plane?
ABC.
A, B, and C. Good. And how many letters do we use to name a line? No.
3.
No.
2.
2. We're naming a line. Good. So line A to B. Okay. I was going to go over something that just completely left my head. All right, Zach, I know you're pretending to be awake, hun, but actually wake up, all right? All right, let's look at intersections. Intersection of two lines. You guys did this all through algebra, those of us that took algebra last year. When two lines intersect, how many points do they have in common?
2. 3. I don't know.
Come on, guys.
What?
1. They only have 1 point.
She was like, you said that first.
So is a point. Well, you started changing it. I didn't say it was wrong. All right, when two lines intersect, their intersection is a point. Most kids can't get that answer. The next one is the one we struggle with. Right, Joseph and Zach? All right. The next one is a plane. That's the one most kids struggle with. So reminder, I said that a plane could be a wall, it can be the ceiling, it can be the floor. Here they're looking at the two sides of the building. If you notice where they meet, it's that edge. And what is that pink line representing? A line. Perfect. When two planes intersect, their intersection is a line. Okay? Always a line. All right. So we're going to practice naming that. First one says, name the intersection of line B to A, which is this one right here, B to A, and line D to C. Point O, right? You're not going to just put O. Point O. All right, next one. You're supposed to do this one, but I will do it with you. Name the intersection of plane Q and plane P. Plane Q is the blue one. Plane P is the red one. It's, what is it?
Line.
A line, which is called line M. My ladies? Ladies? All right, last page. All right, don't be scared of this picture. All right, so remember, a plane is a flat surface. Do you remember pyramids
Yes.
and prisms for middle school? Okay, picture boxes. I have a box over here. All right, let's look at the Kleenex box. We'll do this one. This is fun. That's how many people have. A box. How many flat areas does this box have?
8.
All right, we have 1,
5.
2,
4.
3, 4. What else do we have?
5.
5 and 6. All of these flat faces, they're called faces. All these flat faces, they're all planes, okay? So I want you to look at that picture. Flat faces. That means if you can go like this with your hand,
2.
it's a plane. The first question says, how many planes are there? Look at it carefully. I will say it's not 2.
1. 6.
Not 1.
5.
Oh.
6, Cameron?
3.
There are 6. All right, let's see why. Let's see why. Ready? So, you're going to use your imagination. If this pyramid was in front of you, would you be able to touch all 5 sides? Okay? Right? You would be able to go, if it was a big pyramid, my size, you'd be able to touch all the sides, right?
Yeah.
Now, how many sides does this pyramid have? 1, 2, 3, 4, 5. 5 sides. It also has the bottom, which is how many?
6.
6. But that 6th one is sitting inside this parallelogram. So here's the question. Are there really 6 or are there 7?
6.
There's 6 because this one is already included in the big one. All right. So there are 6 planes here. My kiddos that are falling asleep, I know I told you this wasn't going to be fun, but I need y'all to stay awake, okay? All right, 6 planes. All right, collinear. Collinear. Who can tell me what collinear means? Points on the same line. Good. I want you to give me 3 points that are on the same line here. 3 points.
K, J, and D.
K, J, and D. Good. And because they're points, we're going to write the word points in front of there. Points, J, K, and D. I'm not even going to be picky about the commas as long as you have that word points in front of there, all right? C, name the intersection of a plane with another plane. So I'm not even going to read the name of the planes first. I'm going to identify it. What is the intersection of two planes? It should always be a point or a line. A line. Good. So look, we're going to identify them. I'm going to go to plane HDG. So here's H, here's D, and here's G. So the plane is this triangle. And I know we said on paper planes were going to be parallelograms, but that's just part of a plane. It's not the whole plane, that's just part of it. The other plane is plane X. Here's plane X. So y'all just said, we all came into agreement, that two planes intersect in a line. So the question is, first question is, how many points do we need to name a line? 2. Good. What 2 points does my orange plane and my red plane have in common? H and G. That's your answer. H and G, that line is your intersection. H and G, G and H, I will have both answers, okay? All right, last one on the example. Ready? We're almost done, guys. At what point does line L to M intersect plane X? So at what point does my line L to M, let me erase all this. All right, L to M is here. And then plane X is this red one again. At what point do they meet at? What's the only point they have in common? L. Okay, so let me show you a visual for this one. Point L is the answer. So do y'all see these little dashes? Because that's going to be important when it comes to other assignments. Y'all see those dashes?
Yes.
Okay, what that means is that is no longer inside the plane. This is what the diagram is showing you. It's asking, name me 3 lines that intersect at point E. Guys, you'll see this on the classwork. You're going to see this on the test, okay? So all you're going to do here is you're going to put a point on E. Now, you're just naming me the lines that connected E. That's all you're going to do. So you can give me one line. E to H, so we've already named E to H. E to H, H to E is the same line. What's another one? E to FE? I heard you, Catherine. FE, and who can give me the last one? DE, good. It could be DE, ED, it does not matter. As long as those 2 letters are the ones you chose. All right. Next one, name me a line of intersection between planes, HED and EFH. So my first question is, because it's 2 planes, are we looking for the answer to be a line or a point? A line, good. So this is the trick, okay? So you're going to trace the 3 letters. So I'm going to trace H, E, and D. H, E, and D. And I'm going to finish off that rectangle because this is called a plane. The next one is called E, F, and H. E, F, and H is down here. And I'm going to shade that one in. You don't have to shade it in, but if you can imagine it being shaded in, it really helps. All right, so we said our answer is going to be a line. How many points do we need to name a line? 2, good. What are the 2 points they have in common? 2 points they have in common? E and D, that is your answer. Again, you'll be asked the same question on the worksheet and the test. So make sure you have these answers down so that when you're using your notes and you see that same question, you can look at our example and apply it to your question. Last one, name a line that's coplanar with plane AFH. So let's highlight plane A, H, and F. Oh, let's use purple. A, F, and H. All right, that's the plane I'm talking about. Now, if the line is coplanar, what you're looking for is a line that's on the plane. That's all it is. So a line that's coplanar with the plane, all it means is that it's just in there. It just all contains in there. So in other words, what line is within this purple region? What line is within the purple region? There's 4 different answers. You can give me one. FE, all right. If you answered, give someone else a try. So we got FE. What else do we have? I said someone else. FG, good. Oh, no, FG is not in my purple one. We're looking at the front rectangle.
Oh.
AH, perfect. Someone else? AF, thank you. And the last one. F. HE, good. What did we actually do? We just outlined the rectangle or the plane, right? That's all we did there.